Hello geoscientists. This video accompanies the Geology 101 lab on streams and flooding, and the purpose of this lab is to walk you through the techniques for accessing data from the U.S. Geological Survey on peak stream flow. That's peak annual stream flow. We're going to learn how to download the data and how to analyze the data statistically using Microsoft Excel. So we'll import the data into Excel, our spreadsheet, and we're going to perform some functions, inserting some functions to calculate the recurrence interval in years. So that's how often a certain maximum annual height of a flood happens, how many years in between that level, or the annual exceedance probability, which is the probability of the stream exceeding a certain level in any given year. So let's get to it. This is the lab assignment. What you need to do, you need a computer with a good browser on it, and you need Microsoft Excel installed on the computer. All the campus computers should have Microsoft Excel. If you don't have it, you can download it for free off of the ITS web pages. So take your browser and you're going to go to the USGS website. There are several ways you can do this. You can just type water.usgs.gov. and that will take you to this site. And you can click on this map here, which is a map of all the stream gauging stations in the country. It actually takes you to an intermediate page here, and you're going to click on the map again. And every little dot on this map is a different stream gauging station. So you're going to be accessing data from Duck Creek in Davenport, and I've given you this station number on that. For my example here, I'm going to use data from a different site, so it's going to look a little bit different, but the procedures that you go through are going to be exactly the same. So if we zoom into the Quad Cities, we can see there are multiple stream gauging stations around here. Actually, I think this is a, yeah, that's the Rock River. So to do this kind of analysis, it works better for smaller drainage basins. You're going to be working on this stream gauging station for Duck Creek. So Duck Creek is a waterway that flows through Davenport and Bettendorf. About half of it is rural and about half of it is urban/suburban. I'm going to take a look at Mill Creek down here, south of town, just south of the metropolis of Milan, Illinois. And Mill Creek flows through mostly farmland. There's a few neighborhoods in this area, and then it flows into the Rock River. Here is a stream gauging station for it. So I'm going to click on that icon and then click on Access Data. So this is the main page for Mill Creek. I can look at the current flow conditions in Mill Creek by current and historical observations. Come on, USGS, you're being a little bit slow. So this is what it's doing right now. Here I've got a graph of how high the water is. We call that the stage in feet, or the USGS typically calls it the gauge height in feet, but we're going to call it the stage. So Mill Creek has been pretty boring lately. I can look at it over a 30-day time span, and I can see that some things have changed. Or if I look at it over 1 year, I can see that there are big fluctuations in how Mill Creek flows. So it has a pretty flashy response. We see that Mill Creek, when it rains, over a very short amount of time, that the water level in Mill Creek will rise very, very rapidly. So where you see these really big peaks in the gauge height or the stage, that means it has a flashy response. It rains somewhere in the basin, and that water moves really quickly through the basin. So we got sort of flash flooding potential here. Okay, so I want to go back to my main page for that, for Mill Creek, and I'm going to access the peak stream flow data. So this is a chart, in this case, of annual peak stream flow measurements. So the USGS is collecting data from Mill Creek in Milan, Illinois, and it has been collecting data for many years. And so you can see I've got a data set that goes back to the 1930s, actually, and every one of these dots is the peak annual stream flow on Mill Creek that's been measured. 1 dot per year. In the case of Mill Creek, you don't see any real trend in the data. Some creeks you see, some streams you'll see a distinct upward trend in the peak annual stream flow. That means that for whatever reason, that stream is flooding at higher levels and more frequently than it used to. This is a graph of the actual discharge in that stream, or stream flow in cubic feet per second. So what we want to do is access the data, and we're going to access it as a tab-separated file. So you're going to click on tab-separated file, and here is the raw data. And there's a bunch of header data up here, and if you scroll down, this is the data that you're actually going to look for. So I'm going to download this, and so I'm going to do a right button click, and I'm going to say Save As, and I'm going to give it a text file name, and I'm going to call this Mill Creek 2023 peak. That'll work for me, and I'm just going to save this temporarily to my downloads folder. So there it is. Now what I want to do is open up Microsoft Excel, and I'm going to read that into Excel. So I saved the text file, and you should have seen I saved it as a raw text file. And now I should be able to find that text file. So I'm going to go to Open, and I'm going to have to browse, and I have to move my browser to my download file, and here's Mill Creek. You may need to change your file type to all files or to text files, and you should be able to locate your this particular file. So if I do all files, or I can do text files, and then I see Mill Creek 2023. So you want to open it as a text file, and you're writing it into Excel. Now, this step is really, really important. So this is the import wizard of Excel. You want to specify that the different columns are going to be delimited with a tab. So you're going to click on delimited, then you're going to hit next, and you want to make sure that the tab box is specified. That way, when it reads it in, it's going to read the data into different columns. I'm going to hit next, and I'll hit finish, and things should look good here. So again, here we get now this text file, and if I scroll down, I can see it's actually separated into different columns. And we're going to clean things up here. But before we clean it up, I want to save this as an Excel file. So I'm going to hit Save As. For right now, I'm going to put it right back down in my downloads file, but you probably want to put it into a special file for yourself. But I want to save it as an Excel workbook, .xlsx. And that just saves more functionality like graphs and stuff like that you don't get necessarily with a text file. Okay, now there's a lot of garbage here that I don't really care about. So I'm going to clean this file up. All this is header information as metadata from the U.S. Geological Survey. I'm going to get rid of all that. So I'm going to click on the first file. I'm going to scroll all the way down, or the first line, all the way down to line, in this case, 72. And I'm going to hit, oops, I did it wrong. Click on the first one, and then I'm going to come all the way down. I'm going to hit Shift and hit that line. So I've just highlighted all those, right button click, and I'm going to simply say delete. So deleted all of those lines, just cleaned it up a bit. Now I'm going to clean it up a little bit more. These little hashtags in here, that's because there's more data in there than the column width, so I'm going to make that column a little bit bigger. Now you can see that these are the dates of those peak annual stream flow readings. So there's one every year, starting in 1940, 1941, 42, and so forth. So I've got it here in chronological order. All right, we're only really interested in the peak annual flow, which is peak VA, and the gauge height. So I'm going to get rid of some columns. I'm going to get rid of column D. I'm going to highlight all of column D, do a right button click, and just delete it. Right? I'm going to do the same with column E and F. I'm sorry, no, just column E. I'm going to delete column E, and then all these other columns to the right, I'm going to get rid of those. So I'll just say hit delete. So now I'm left with peak VA and gauge height. Also, I'm going to get rid of line 2 because this is just header information for the USGS. It doesn't really matter to us. Okay, now let's give these columns some column headers that mean something to us, especially gauge height. We're going to call this stage measured in feet. So that is the water level measured in that location at that stream gauging location in feet relative to a datum that they have established. So they've just called some point there 0, and it's measuring the height of the water relative to that in feet. So I'm going to call it stage. USGS likes the term gauge height. I prefer stage. Now I need to enter in some more data here. And to do this, I'm going to be following the directions on your lab assignment. So I've given you the instructions for this, and you're going to be creating some new columns in here. You're going to be making a column for the recurrence interval. That's the number of years between a peak annual stage of that level. And that I've given you the formula of recurrence interval equals n plus 1 over m, but m is the rank of each one. So what I need to do first is I am going to sort all of the data here. So I'm going to come over here and highlight, all the data in those 4 columns down to the end. I'm going to highlight all of those, and then I'm going to say, then I'm going to sort them. And what I want to do is sort it from the highest stage on record to the lowest stage on record. So I'm going to be sorting it by column E. So I'm going to come up to data. I'm going to choose sort, and I'm going to sort by, I'm going to say, because I didn't highlight the headers, I'm going to say the data does not have headers. And then I'm going to say sort by column E. And I want it to be largest to smallest. And I'll hit OK. And if I've done that correctly, I should see the highest stage on record, which in this case for Mill Creek was in 1973, at the very top of the record, in this case 11.65 feet. And the lowest peak annual stage on record is 3.7 feet, and that was in 1940. Again, your data are going to look different because you're looking at a different stream, but it should go highest to lowest. And because I highlighted all of those, the data in all of those columns, it sorted them all exactly the same. So the peak annual flow here, this is in cubic feet per second, also goes from highest to lowest. Okay, so now I need to do some calculations. First thing I'm going to do is rank these. I'm going to call this column rank, and that's going to be, we're going to designate that with a letter M. And that's a simple idea of just ranking them from 1 as the highest to whatever number in however many data lines you have in your series. So I'm going to call this 1. That's our highest peak annual flow, so I'll call that 1. And then now in our second line, I'm going to highlight that. I'm going to type a formula. I'm going to hit equal. And I'm going to highlight then the column above it, which is going to be F2, and then I hit plus 1. So that just made it 2. Now you could go through and you can number all these yourself, but I've just made it easier for myself. I gave it this formula, and now I'm simply going to copy that formula, Control C, then highlight all of the fields beneath it, down to the bottom, and I will paste that formula in there using Control V, or you can do, I think, a right button click. So now I got 1, 2, 3, 4, 5 all the way down to the bottom, and I see I have 81 years on record. So the lowest peak annual flow of 3.7 feet would be a rank of 81, and that occurred in 1940. So you'll be doing the same for Duck Creek. I like to center my data, so I'm going to highlight some columns, and I'm going to center the data just so it's a little bit cleaner. All right, now we need to do just a couple more things. We need to calculate the recurrence interval, and we're going to call that R for recurrence interval, and that is in years. And the recurrence interval formula is n plus 1 divided by m. Now n, as in Nancy, n is the number of years in record. So that would be the recurrence interval, the rank in this case of 81. So how many years on record you have, that is going to be N. So in this case, if I have I have 81 years on record, N plus 1 is going to be equal to 82. So this R is going to be equal to 82, and then it's going to be divided by the rank for that particular line. So I'm going to say 82 divided by, and then highlight the field right next to it, F2. Hit return. So in other words, 82 divided by 1 equals 82. Now I'm going to highlight that formula of N plus 1 divided by M. I'm going to highlight that formula. I'm going to copy it. Then I'm going to highlight all of the fields beneath it. And I'll do a right button click, and I'm going to paste that formula in there. I think it's this. No. Hit paste. There we go. So now I've just pasted that formula down. Now you see that the recurrence interval is decreasing over time. And the last thing I'm going to do is make a column of exceedance probability. I'm going to call that column P, and that's going to be in percent. This will be the annual exceedance probability of a flood of that level. And so now I'm going to, the formula for that I've given you is 100% divided by R. So I'll give it a formula equals 100 divided by our recurrence interval, which is the field right next to it, G2, and I hit return. So in other words, now what I'm saying is that a peak annual flow of 11.65 feet should occur once every 82 years, or it has an exceedance probability in any given year of 1.2%. Now I'm going to copy that formula, and I'm going to paste it into all of the columns beneath it, all the fields beneath it. And there we go. Now we should see in the probability that it goes from a very low probability to a very high probability, because it's basically the inverse. Now I'm going to clean this up just a little bit more. I'm going to highlight all of column G and column H, and I'm going to reduce the number of decimal places that it's showing us. Oops, sorry. Got to get rid of that. I'm sorry. I messed my data up here a little bit. Got to fix that. Copy, paste. There it is. Okay, sorry. I messed that up a little bit. So now let me do that again. If I highlight all of these columns, I should be able to reduce the... No, I know the problem because I need to do only the data. I highlight all of the fields with data in them, and now I can reduce the number of decimal digits down to 2 decimal digits. That just makes it a little bit cleaner, a little bit easier to see. Okay, now I'm going to stop this video, and I'll do a second video on our graphing.